In this section, I want to talk a little bit about the history that brought us up to this point with ASP.NET MVC. And usually history is sort of the most boring part of exploring a new technology because you want to jump right into all the good stuff and all the stuff you can use right away. And I'm kind of that way too, so I understand that. But at the same time, why you're going to use MVC relates a lot to your alternatives and what's come before it. So it's important to understand what you might have done without MVC, because you don't want to latch on to a new technology just because it's new or just because a particular company has some marketing muscle behind it. You actually want to understand what value this is giving you over other things you might use or the things that have come before it. Why is this new technology so much better than the technology that preceded it? So I want to spend a little bit of time talking about the different pieces that have come before MVC as we know it. The main stages of this history are going to be HTML, ASP or Active Server Pages, this is also sometimes called Classic ASP, ASP.NET Web Forms, which is a current Microsoft technology, and it was pretty much the first web-based technology that the .NET framework introduced. And then finally, we will talk about ASP.NET MVC and how it stands against these things that have come before it. So the first thing I want to look at is HTML, or Hypertext Markup Language. If you've used the web very much at all, you know that this is the language that sort of drives web pages. It was designed in 1980 by Tim Berners-Lee, and what most people don't know is that it was originally meant to be markup for text documents to allow scientists to share their research. Now, this is important because the web that we work with today, it's highly interactive, it's full of images and video, it's used for applications and games and all sorts of things. But it's important to remember that the web's roots are in text documents that scientists are going to use kind of like electronic journals to share their research. And so this explains the presence of certain elements in HTML like tables, for instance. So you can have tables of data or different layers of headings or, hyperlinks to link between related pieces of research. So this is sort of the cauldron HTML was born in. Now, since 1980, it's gone through several standards revisions, and we are currently working with HTML5 today. So it's gone through several versions and several half versions. But it's primarily a static language. It has no real functionality built into it. Even HTML5 is this way, and this is something that gets obscured sometimes when people talk about HTML, because HTML today integrates so many other technologies. It's important to realize that HTML itself is simply markup. All it does is mark up text so that text can be presented in a browser. And it's the browser that does things like downloads the images and puts them in the right spot or runs the video animation or things like that. HTML by itself can't access databases. It can't do dynamic slideshows. It can't do any of that stuff by itself. And so early on in the Internet's history, this is pretty much all we had to work with. Now, you could do a little bit of client-side manipulation of web pages, but you needed other language to do it. So you might use JavaScript, for example. It was probably the most popular language to manipulate pages client-side and really still is today. But still, what we're missing with pure HTML and even HTML with JavaScript is some server-side interactivity. And what I want to do is take a look at this just so you can have a point of comparison between this and the server-side activity of MVC4. In order to really appreciate the differences between what's come before MVC and what MVC can actually bring you, I wanted to take a minute and show you just a regular static HTML document. Now, many of you have probably seen this before, seen HTML before. If you've never seen it before, you can find it really easily. If you are on the internet and you're on a web page, you can right-click on something and view source and see it. But this is just sort of a plain static HTML document. As you recall, the reason that that HTML was invented was primarily for scientists to share their research. So I paid tribute to this with some very highly confidential, sensitive scientific data. The threat levels of different animals, starting with housefly and working all the way up to bears with lightsabers. So this is important research that most scientists would want to have their hands on, so it's kind of a privilege to see it right now. But what I really want to draw your attention to is the fact that This is just a text document with markup in it. And what's going to happen is when a web browser opens up a document like this, it uses the markup to render it in certain ways and to do some formatting and some basic display kinds of stuff. And even hyperlinks, even the things you click on, are just text. It's just static text that the browser is actually going to portray as something a little more functional. And as you can see, there's not really any programming code or anything in here. There's a little bit of CSS in here to make the table look nicer, but there's nothing in terms of actual functionality. There's no calls to a database. There's nothing that automatically generates emails or copies files or anything like that. HTML just does not have access to that kind of functionality. It's just sort of a static client-side document. Now, if I actually open this up in a web browser, you'll see it interpret this document and format it in certain ways. I open this up. And now you see something that you're used to seeing on the internet, or something you might have seen in the internet in the mid-90s. Hopefully you don't see too many pages that look like this anymore, but you get the idea. What the browser's done is it's taken this default.html file and it's taken all the text and the markup and it's rendered it in certain ways. And so we've got the text, we've got the heading formatted this way, we've got our nice highly scientific table of data here that will change the world if it ever gets out. And we've even got a hyperlink here I can click on to go to google.com. But ultimately, all of this is just static text. In fact, I can go out here to an empty area and right-click, choose View Source, and there's my HTML document. It's the same thing you saw in the development environment. So even though we can get across static information this way, and this ruled the day for several years, what we're missing is that interactivity, the ability to dig into data sources or the ability to dig into multimedia or other kinds of response types like PDFs or Word documents and be able to present those easily over the internet. So as we go through history, we'll be able to see how we dealt with this problem. As you know, HTML is just basically a static text document. It doesn't have a lot of interactivity to it beyond just the presentation of static content. Well, in order to deal with this, various places and companies and individuals even came up with some technologies that would enable us to put things in HTML pages that actually had some programmatic functionality to it and could reach back into data sources and other servers. ASP, or Active Server Pages, is Microsoft's entry into server-side languages. Around 1996 is when they first started getting into this area. And the reason this was such a revolutionary change in terms of the delivery of web pages is that it actually allowed server-side functionality, things like working with databases, or reading and writing from text files, or even sending email. Now, ASP, because it was just something you put in web pages, it was done on a scripting versus an object-oriented programming model. In fact, originally in ASP there were only 5 objects, and they weren't ones you coded yourself. They were ones that were built in that you had to use. And so those of you that come from an object-oriented programming background and you recognize things like classes and interfaces and those kinds of things, that was completely absent from ASP. It was almost entirely an inline procedural scripting model. It also tended to result in code that was a little bit difficult to maintain and reuse because what you're doing is you're taking an HTML page and you are just sprinkling it with ASP code wherever you need the dynamic content. And so, unlike, say, an object-oriented programming language, using ASP was what we sometimes call spaghetti code. It was just programming code that was all over the place. So even though it worked, and it worked well for what it was trying to do, it still had code that was very difficult to maintain and reuse, especially for those of us who come from more object-oriented programming backgrounds. Taking a look at an ASP page, you'll notice that it looks remarkably like a regular HTML page, but there's a few key differences. First of all, you'll notice it has this ASP extension on it instead of .html, and this is how the web server knows that it's going to have some processing to do before it actually renders HTML. And if you look at the page, It's just basic HTML, but here and there are these little weird characters that tell the web server that here's some code that it actually needs to process. So for example, here in this paragraph, what I'm doing is I'm getting the current date and then I'm displaying the year out of that date. If I go down here to where our table of threat levels were, I've got this static content here for the headings, but here I create arrays of animals and arrays of danger levels, and then I just write a little loop to create my table rows with that data dynamically inserted in there. Now you might imagine here I just hard-coded some arrays, but these could easily be calls to databases and looping through database records. But the point I want to make here is notice the way this code actually interacts with the HTML. It's just slapped in there where I need the output. So there's really no concept of like creating classes and objects that I can reuse or even test meaningfully. It's just like a scripting language. In fact, it's literally a scripting language that just happens to be processed on the server side before HTML gets sent back to the client. So when your browser requests an ASP page, the server, before it serves it up, goes through the page, finds these little marks, and it processes that code to produce HTML, and then it returns whatever it produces to the web browser. So if I actually run this page, you'll notice it looks pretty similar to the other one. Notice the year is 2013. This wasn't static text in my HTML. This is something that year date function you saw actually produced. And you'll remember that my document didn't have any HTML in here for the table. It just had scripting instructions to tell it how to draw a table and what data to put in there. And that's exactly what it did. So the web server put all that together, and it just inserted it into the HTML where the code actually was. Now if I view the source code of this guy, I see the HTML that I would expect. Okay, it's a little messy, but it's table cells. It's just static HTML at the end of the day. However, the web server did process that code to bring me the HTML. So now we're getting closer. When you look at Classic ASP still works. You can still access databases and do all the dynamic stuff you want. The problem is that my code gets sprinkled all throughout my web pages, whether it's database code or display code or whatever kind of code it is. It's all over the place, and it's not really in consumable ways that I can easily maintain and test and reuse over and over. So that's what brings us to our next point in history. One of the more revolutionary points in the history of web technology and interacting with the server was ASP.NET Web Forms. This was introduced with the .NET framework in 2002, and it was meant to bridge the gap between web development and Windows software development. And it's important to understand that because there's some things about web forms that if you come from other programming backgrounds, the model might not make immediate sense to you. But when you understand that what Microsoft was trying to do is take everything they were doing in Windows development and bring them to the web, then it makes a little bit more sense. For instance, it uses controls that are handled by a code behind file, which is similar to Windows applications. So when you're making your web pages, instead of having lots and lots of static HTML, instead you've got button controls and text box controls and all the things you're used to working with in a Windows form application. And then you have code that sits behind those in a file that processes the events. So when you click on a button, this code that's in the code behind file basically says what needs to happen. And if there's dynamic text that needs to be displayed, then those get displayed in label controls and literal controls. So it's very much kind of a Windows form-driven architecture, but applied to HTML. Now this performs better and is much more maintainable than classic ASP because what's going to happen is in your document where you would normally put your HTML, and you can still put HTML in there, instead of having spaghetti code scattered all through it, you're going to have these references to controls that are in the HTML. It's much cleaner, and all the programming functionality that drives those controls is in a completely separate file. So if you've ever seen an ASP file, you know that there's all this programming code intermixed in with all the display. And this is actually moving us forward into the separation of the display elements and the functionality that actually drives them. However, it does use a lot of overhead to simulate desktop software interactions. The web is a stateless environment. When you pull up a page, it instantly forgets who you are. It just served you up the page and it's done. It doesn't know when you click a button that you had entered all this stuff into text boxes. There's no sense of it preserving that web page. Well, with ASP.NET Web Forms, they wanted to try to recreate that persistent Windows environment. So there's all these mechanisms that work under the hood to try to make web pages behave more like a Windows application, including that persistent state. So if I fill out a bunch of text boxes and click a button, what ASP.NET wants to happen is that form will post, but I'll still have all those text boxes filled in. It'll basically look like the screen never changed except for whatever behavior has to happen. And there's just a lot of overhead that goes into doing that. So let's take a look at this particular choice in web development. So now we're in Web Forms world. And all I've got here is the default Web Forms application that Visual Studio generates when you ask it to start a new Web Forms application. But I did add a few things to it that I'll get to in a second. The first thing I want to point out is that it looks like initially what we've got here is basic HTML, and in fact you even see a little bit of the same delimiters that you find in classic ASP. But I want to draw your attention to something a little bit different. Notice this guy here. This is a Web Forms control. In other words, this may look like a snippet of HTML, but it's not just static HTML. It's all wrapped up in this content control, so this can be dynamically inserted into other pages. They do the same thing down here with a content control, and you'll notice this attribute run at server. That's a dead giveaway that this is actually going to have some server-side code behind it. And I also added a few things of my own, kind of keeping with the motif of finding out what animals are dangerous and what animals we have to deal with. I added a button and I added a table. Now you'll notice this doesn't look a whole lot like the HTML equivalents of buttons and tables. That's because these are controls. And once I've made these controls and allow them to run at the server, then I have programmatic access to them. So what happens when a user clicks this button? Well, in order to see that, we have to go to the code behind file, which has all the programming logic for this page. And you can see what happens when we click that Get Animals button. Here's the code that's going to run when that button is clicked. Now, if all this code doesn't make a lot of sense to you, that's fine. What I just want to illustrate at this point is the fact that when you click that button, the programming functionality behind it is carried in this separate file. I don't have to spaghetti that into the web page, kind of like classic ASP forces me to do. So in this case, it's just going to add one row to our table and display that. So nothing particularly fancy. But when I run it, I want to show you how different this looks. Now, because this is our default Web Forms application, initially the styles are all in there. There's a lot of stuff that sort of comes out of the box that you can take a look at. So this page will look a little bit nicer than the pages we've been looking at before because of the cascading style sheets. But you can see here's some of the static text that you saw in the snippets of HTML. What the server's done is it's taken those HTML snippets and put them into those content controls that we were looking at. Now here's the button that I put at the bottom of the page, and when I click it, we get a row added to this table. Now the interesting thing is when I clicked this button, this actually posted back to the web server and it reloaded the page. But you'll notice the page looks pretty much exactly the same. In fact, if you've got a fast enough internet connection, you might not even see the page flicker. It's hard to tell anything has actually happened. Well, this is kind of the genius and the vision behind ASP.NET Web Forms, is to try to make this page work as much like a Windows application as possible. But let's take a look at how it gets this done. If I view the source code of this page, you're going to see some things that look familiar. I mean, ultimately, we're getting static HTML. All right, so we saw this with classic ASP as well. And if you look down here where I had my button control, this is the HTML it produced. And where I had my table control, this is the HTML it produced once I added this row. So in terms of the end result, it probably doesn't look too much different than classic ASP. But I want to draw your attention to a couple of things up here at the top that I just sort of skipped over. One is it added some JavaScript to this page. And this JavaScript is going to create a form that when I click a button or click a link or do anything, it's going to make the form submit. So everything on this page is going to be treated kind of like an HTML form. Well, if you've ever worked with HTML and forms before, you know that when you click a submit button, even though you're submitting all that data to the web server still forgets all about you. When it loads a new web page, it doesn't remember that you were on a form. It doesn't remember the values that you put into that form. It doesn't even remember it was you. So how does Microsoft simulate having a Windows environment? How does it remember what was on the form and what the form looked like? And all that magic is bundled into this incomprehensible piece right here, the view state. What Microsoft does is it takes all the dynamic values from the controls in your web page and it encodes them into this magic value here. Now, don't ask me to interpret what all this stuff means because I don't know. That's a proprietary Microsoft secret. They probably took those developers and sealed them away in a vault somewhere. But what happens is when you post the form, this encoded value goes with it. And when the server sends the page back, it knows what this value is, and so it can redraw and repopulate all the controls to look exactly the same way they did before. So they'll have all the same values. It will be like really you never left the page because it's transmitting those values back and forth in this secret code. Well, there's a sense in which this is kind of genius. But there's also a sense in which there are some liabilities that come along with this as well, because I just have a few controls on this page, but you can imagine, if I had lots of buttons and lots of form fields and lots of functionality going on, well, this encoded value could get pretty huge, especially if I'm hitting a database and bringing back a lot of records. This encoded value could be several K's worth of code and could really make this page take a long time to download. The other thing is that this value has to be kept in sync all the time, and as web technology has progressed and people start doing more things with JavaScript and messing with form values and messing with objects on the page to hide them and show them, it's pretty easy to get this value out of sync from what's actually on the screen, and it breaks the whole mechanism. So even though web forms are a good solution to some of these problems, there are also some trade-offs, just like any technology. Now, I want to point out that ASP.NET Web Forms is not going away. Microsoft is not getting rid of this technology, and it's a perfectly viable solution for your .NET applications. However, in response to the developer community talking about things like view states that are heavy, or post-back models that get corrupted too easily, or even just the ability to write programmatic classes that you can unit test instead of having a code-behind file, that's what drove the push ultimately to develop the MVC framework. And that's a unit of history we will also take a look at. So finally we get to ASP.NET MVC. This was introduced at the Alt.NET conference in 2007 by Scott Guthrie, so it's still pretty young in a lot of ways. It's rapidly progressed up to the current version. We're already on version 4 in just a very short span of time. It is not meant to supersede web forms technology. In other words, these two streams are meant to go on in parallel. They just are two different ways to solve similar problems. One isn't the new replacement for the old. And then finally, the framework was designed to make it easy to implement the MVC design pattern in .NET web applications. So it's important to note that MVC is a design pattern. ASP.NET MVC is the framework that ASP.NET uses so that you can easily use this pattern in web applications instead of the old web forms model. When we take a look at an MVC project, When you look at the markup, it actually has some ingredients from all the points of history that came before it. You have little code snippet segments, and you have a little bit of inline, but you'll notice that the inline things you see in the MVC are not blocks of programming code, but they are just little tags to display bits of information. What you'll notice that it doesn't have are any controls. It is all just static HTML with little bits and pieces of reference code in here for display purposes. And that's because in MVC you have a view which basically functions as the web page, and it is totally ignorant of any kind of data or functionality or any server-side connections that might be fed to it. All that stuff is contained in models. This is where we find our data that gets into these web views, and the controllers, which is responsible for putting the data into the web views and doing a lot of the processing that you might have normally found in a web forms code behind file. So you can see that it still operates very similarly in some ways to classic ASP and ASP web forms, but what it does is it strongly divides out the responsibilities. So we get the maintainability and testability and reusability of object-oriented programming. We get separations of the view and the programming and the data, but at the same time we have the flexibility to just integrate our pieces of dynamic content right into our HTML exactly where we need them and how we need them.